Hello everybody, welcome to Voices of Friedreich's Ataxia. Our goal is to raise awareness and funds to cure Friedreich's Ataxia, FA. Today we will talk about genetic testing in Friedreich's Ataxia. Genetic testing analyzes the FXN gene, which is the only gene identified to cause Friedreich's Ataxia. Positive genetic test results for Friedreich's ataxia usually contain two numbers that indicate presence of the disease. What do these numbers mean? Our genetic code is spelled out along the double helix of our DNA by triplet combinations of four nucleotides labeled A, T, C, and G. At the key place in the FXN gene of a person not affected with the disease, only a dozen or so triplet combinations of the nucleotides GAA would be found. In a person affected with FA, however, this combination of the GAA nucleotides is usually repeated hundreds of times, making it very difficult for the normal part of the gene to be read or transcribed, thus, limiting the amount of frataxin protein that can be encoded and formed. For FA, in 96% of affected individuals, the two FXN gene alleles have GAA triplet repeat expansions that silence expression of the gene, preventing enough frataxin protein made for function in the mitochondria. The two numbers in the genetic test reports refer to the number of GAA triplet repeats on each allele copy of the FXN gene. One number is associated with the allele, gene, inherited from mom, and the other number is associated with the allele, gene, inherited from dad. The expanded numbers of the GAA triplet repeats confirm the inheritance of Friedreich's ataxia. Research seems to indicate general correlation between some FA symptoms and the numbers of GAA repeats. In almost 4% of people affected with Friedreich's ataxia, the genetic test report includes one allele of the FXN gene with a GAA triplet repeat expansion and the other allele with a single nucleotide change, called a point mutation, or a deletion in the FXN gene. Changing a nucleotide of A, T, C or G to another nucleotide often causes a change in the frataxin protein structure, thus, causing a change in frataxin's ability to execute its function. A gene deletion removes a section of nucleotides, which can also result in loss of FXN gene expression and frataxin protein function. This information was taken from FARA Australia with their permission. Their link is provided in description.